All right, y'all. So today we're going to be talking about advanced exponent properties. We're going to start off with two students that are having a bit of an argument. Trey believes that a to the 0 equals 0, and Troy believes that a to the 0 is equal to 1. We want to think about who's correct. And to kind of help us out with this conversation, let's consider what happens when we simplify each of the following. So if we have 3 over 3, 3 over 3 we know would divide each other out and would be equal to 1. Same with z over z, which would divide each other out and would be equal to 1. X to the 5th over x to the 5th, we know, just like everything else, should equal 1. But let's do a little bit of extra work. X to the 5th over x to the 5th, that 5 over 5, they are being divided, so we would subtract those exponents. So x to the 5th divided by x to the 5th would be 5 minus 5, so that would be equal x to the 0, which does equal 1. And likewise for our a to the negative 31 over a to the negative 31, those would divide each other out, give us a to the 0, which would be equal to 1. So going back to our original question, I don't think Trey's correct with his a to the 0 is equal to 0, but Troy's belief that a to the 0 is equal to 1 is true. And so in general, anything to a 0 exponent is always equal to 1. So no matter what, if anything is taken to the exponent of 0, it's going to be equal to 1 and it's going to cancel out. So let's kind of expand a couple of these without doing our exponent properties and see what conclusions we could draw. So go ahead and think of some of those expansions we've done before. Go ahead and pause me and see which ones of these you can match up without me. And then I'll talk about them here in just a moment. All right, y'all. So looking across these, hopefully you got some similar answers to me. If you weren't quite the same, that's okay. We'll talk about them here for a bit. So our m squared cubed. So if we are cubing m squared, that'd be the same as m squared times n squared times n squared, which m squared is the same as m times m. So we can see that that one represents a. C m cubed squared, same thing but in reverse, m cubed times m cubed, because we have two of those m cubed, which would be mmm times mmm, which would give us c. Now 3, 4, and 5 are kind of what I would say are kind of the hard ones. So on 3 we have 2m cubed, so only the m is being cubed, so it would be 2 times m times m times m, which that 2mmm is the same as 1mmm plus 1mmm, which would give us 2mmm, which means E would be our match for 3. But then on 4, a little bit different. The 2 and the m are being cubed, so that would give us 2m times 2m times 2m. And 2m is the same as 1m plus 1m. So that would mean number 4 matches up the best with B. And then last but not least, on number 5, 3m squared, kind of similar to number 3, that would give us 3 times m, so 1mm plus 1mm plus 1mm. So D would definitely be our best match. Now, one of the conclusions we want to draw from here is how can we simplify m squared cubed or n cubed squared without having to expand? Because that's kind of our goal with our exponent properties. We don't want to have to write these out every single time. Well, if you notice, m squared cubed is equal to m squared times m squared times m squared. And if we did our product property, that would be the exact same thing as m to the 6th. Likewise, over here, m cubed squared, m cubed times m cubed, would also be equal to m to the 6th. Okay, so the conclusion that we can draw from this is that when we have that, what we call a power to a power on the inside of parentheses and a power on the outside of the parentheses, how would we get 6 from 2 and 3? Well, we would multiply them. So 2 times 3 is equal to 6, and 3 times 2 is equal to 6. So we call this our power to a power property. So if I have a m to the n, then it would be equal to a to the m times n. So as an example, if I had x to the 5th cubed, that would be equal to x to the 15th. So let's put this into practice. Let's look at number 6. We have b to the 7th squared. That's 7 and 2 are power to a power, so we would multiply them to give us b to the 14th. Same idea over here on number 8. H to the negative 5th squared. Negative 5 times 2 would give us h to the negative 10. And then adding in our negative exponent, that negative 10 would make us go to the bottom, so 1 over h to the 10th. Now I skipped 7 for a reason, because 7 is just a little bit different. You notice we have x cubed over y squared, so we have multiple things inside of those parentheses that are all being taken to a 4. Okay, and you might have thought that we should still do our power to power, but do you multiply the 3 by the 4? Do you multiply the 2 by the 4? Do you need to divide them first? Well, the answer is we apply that power property to everything on the inside of a fraction as long as it's all being multiplied or divided. So this 4 would multiply in the 3 and multiply in the 2, so it would give us x to the 12th over y to the 8th. So we still apply that power to a power property, but across everything that's being multiplied or divided inside. Okay, so let's do a couple to kind of finish things out. So let's look at number 9. We have a b to the 4th c squared cubed. So to help us out, I could just go straight into doing a power to a power, but remember how we talked about that exponent of 1 and how we only write it sometimes? Well, I'm going to go ahead and add it in and write it now. So that gives us a to the 1st, b to the 4th, c squared. And I think this is going to help us with a multiplication because we have a to the 1st to the 3rd, so it's 1 times 3, so that would give us a to the 3rd, b to the 4th to the 3rd, 4 times 3 is 12, so b to the 12th, and then c squared to the 3rd would give us c to the 6th. So the reason I added in that 1 is so it's easier to see that we're doing 3 times 1 to get that a cubed, as opposed to like 3 times 0 or 3 times nothing. We want to make sure everything gets that exponent. Okay, now number 10, same idea. We have our x cubed, but this 2 right now does not have an exponent. So let's go ahead and write it 1, 2 to the 1st. So 2 to the 1st to the 5th would give us 2 to the 5th because we do 1 times 5. And then x to the 3rd to the 5th would give us x to the 15th because we do 3 times 5. And then that 2 to the 5th we could simplify a little further because 2 to the 5th would be 2 times 2, which is 4, times 2, 8, times another 2, 16, and then times a 5th 2, 32, and then x to the 15th. All right, so hopefully you're kind of getting the hang of it, y'all, but let's do just a couple more together. So we have this one, 10 q to the 9th, r squared to the 3rd. So let's add an exponent of 1 onto our 10. So 10 to the 1st cubed, we would multiply, so that would give us 10 to the 3rd. Q to the 9th to the 3rd, 9 times 3 is 27, so q to the 27. And then r squared to the 3rd, 2 times 3 would give us 6. And of course, if you're ever not comfortable doing some of this multiplication, y'all feel free to use your calculator. You would be able to use it when simplifying any of these. And that 10 to the 3rd, 10 times 10 is 100, times another 10 would be 1,000. And then, of course, we'd still have our q to the 27 and r to the 6th. And our very last one, y'all, we have our 12 with that negative on the outside, 7 cubed, q to the 7th, t to the 3rd, but then all being taken to the 4th power. So we talked about this before, that when we have that negative on the outside of a parentheses, we are not going to apply that negative until the very end. So I'm just going to rewrite my answer with that negative on the outside because I know that negative is going to be on the outside of the parentheses, so it's not going to get multiplied in. So 7 to the 3rd to the 4th, that 3 times 4 would give us 7 to the 12th. Q to the 7th to the 4th, 7 times 4 is 28, so that would give us q to the 28th. And then t to the 3rd to the 4th, 3 times 4 would give us 12, so we get t to the 12th. And then simplifying to finish up, y'all, we have negative 7 to the 12th. Notice again that negative stayed out front because it's not being taken to that power of 4. So even though our even powers usually make negatives positive, it's not actually being taken to that 4th power. 7 to the 12th, q to the 28th, t to the 12th. So let's go ahead and simplify that 7 to the 12th, which is going to be a pretty big number. So it might be too big for us to write, but let's check. So using our calculator, we can do 7 to the 12th. And yeah, see this E right here? This means that number is way too big. So we're just going to leave it as 7 to the 12th on our final answer. And of course, that negative is not being taken to that 12th power, so it's not going to make it a positive 7 to the 12th. It's going to stay negative 7 to the 12th, q to the 28th, and t to the 12th. All right, y'all, that's really all there is to our exponent properties. Obviously, they can start to get more complicated as you start to put them kind of together. But go ahead and work on some of that practice until you feel comfortable and feel like you can take our exponent properties exit ticket on Mastery Connect.